Hi everybody, welcome back to class. For this video, we're going over this last little section as our introductory / review of material going into the chemistry year. And we're looking at volume. Now volume you probably studied before, but volume is just a measure of the amount of space an object or a substance takes up. So how much space it takes up. And anything that is made of matter will take up space. Tables, chairs, people, any of those take up space. Even air takes up space. If it didn't, you wouldn't be able to blow up a balloon. So anything that takes up space is made of matter. In this class, the two most common ways we're going to be measuring matter will be using milliliters and cubic centimeters, with the more common of the two being milliliters, because that's how we're going to measure with graduated cylinders. And down below you see the three pictures, which is showing you how we're going to do the three different measuring styles, which will be of cubical objects, liquids, and oddly shaped objects. But looking at this first, we're looking at metric units of volume. Again, for the liquids, we're looking at milliliter and liters. Milliliters are pretty tiny. Only about 20 drops of water are in every milliliter, so it's not really that much. Liters you're used to buying because that's how you would buy your soda down at the store. You can buy it in liter bottles, 2 liters of bottles, and a liter always has 1,000 milliliters. 1 liter has 1,000 milliliters. Now down below here you do see the metric units. We have milliliters and liters, which are going to be for liquids, and cubic centimeters and cubic meters, which will normally be for solids, but these are interchangeable. And the reason they're interchangeable is right here with the milliliters and cubic centimeters. 1 milliliter equals 1 cubic centimeter, no matter what you do. So that means if you have 2 milliliters, something with a volume of 2 milliliters, it also has a volume of 2 cubic centimeters. 1,000,000 milliliters, 1,000,000 cubic centimeters. And that conversion allows us to go back and forth between the two. Though for liquids, it's usually going to be milliliters and liters, with the majority of the time in this class, about 90% being milliliters, and solids being cubic centimeters or cubic meters, with again 90% of the time it being cubic centimeters. Now the first thing we're going to look at is something that you have done in math class probably all the way back to middle school, maybe elementary, is looking at the volume of a cubical or a regularly shaped object. When we measure the volume this way, we are going to be using length times width times height. And this is going to be in cubic centimeters. This is how you get cubic centimeters, because you got to take centimeters times centimeters times centimeters equals centimeters cubed. Now in your homeworks, whenever you start working with this, you are going to be using a Google form. You can't write centimeters cubed, so what I'm going to have you do instead is you're going to write it as CM3. And this will be in the Google Forms. So you got to write it as CM3, lowercase c, lowercase m, the number 3. That'll let me know you mean cubic. Centimeters, just using centimeters would be wrong. It has to be cubic centimeters. Now when you're doing this, also remember, it doesn't matter. Whenever you're trying to tell someone what the length, the width, and the height is, most of the time you'll see stuff like length, you will see width, you will see height, but it doesn't matter whenever you actually go to multiply, because the order of multiplication doesn't matter. For example, 5 times 2 equals 10. 2 times 5 equals 10. No matter the order, you still get 10. So no matter the order you would multiply here with the 3, the 4, and the 5, you're still going to come up with a number of 60. Just make sure, again, you have the units centimeters cubed. 60 centimeters would be wrong. That would be a wrong answer. So anytime you have a cubical shaped object, it will be length times width times height. Now we're going to look at volume of liquids. Liquids, this should be volume of, I added an extra A there. Volume of liquids will be measured using milliliters or liters. And again, the majority of the time, milliliters being the go-to. And milliliters is lowercase m, capital L. Liters is just capital L. And these are going to be measured using graduated cylinders. Now, with the graduated cylinders, there are steps to measure the liquids, but it's pretty easy. 1, you pour the liquid in. Common sense there. 2, you got to get eye level with the liquid. This is where people make a mistake. They try to read it from looking down at it or looking up at it. You actually have to get eye level with it, just like it's showing over here. You got to get eye level with the water or liquid, whatever's inside of it. And then once you get eye level with it, you got to read from the meniscus or the bubble. And if I zoom in over here, you can see what I mean. You get eye level, and the water doesn't go straight across. It forms this bubble here. That bubble is called the meniscus. And you're going to read from the bottom of the meniscus every time. Some graduated cylinders don't form a meniscus, so you would just read straight across. But if there's a meniscus there, you got to read from the bottom of the meniscus. And then you're just going to record the volume with the proper number of decimal places. In this class, all your measurements that you have in lab, maybe not in practice, but in lab, will have 1 decimal place. All the graduated cylinders in class will measure 1 decimal place. That means 1.0, 24.3. And you're also going to have the unit milliliters whenever you're measuring the liquids. The example that I have is over here on the right here, in this light blue graduated cylinder, the light blue water. If you would read from the top of the meniscus, the answer would come out to be 25.0. But it's actually from the bottom of the meniscus, the answer is 24.0 milliliters. It's 0.0 because it's dead on that 24. You're also going to have to make sure that you properly read the number of tick marks. Count it out to yourself so you know if it goes up by 1s or if it goes up by 2s or if it goes up by 0.2. So here's some examples of graduated cylinders. Number 1 here. Number 1. What would be the volume of this liquid? Well, you got to figure out how much does each one go up by. So let's start at 40. 41, 42, 43, 44, 45, 46, 47, 48, 49. Okay, so we're good there. It goes up by 1s. Real easy. So 41, 42 right there. So we know it's 42. Because it goes up by 1s, it's going to be 42.0 milliliters. The reason it's 0.0, on this graduated cylinder, we know for sure right there is 42. We know for sure right there is 43. But in between here, we don't know for sure. And in between is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So you can guess 1 decimal place. If you ever need to ask yourself, ask yourself, what's between 42 and 43? 42.5. If you say 42.5, it must have a decimal place. Let's go on to the next one. How much does each tick mark go up by? Well, let's count it. Always start at 1s there so you can just kind of go with it. So 15, 16, 17, 18, 19, 20. Good, we're good there. So it goes up by 1s. So if it goes up by 1s, it's right here in this line. We know it's 20. Well, ask yourself, what's between 20 and 21? 20.5. 20.5 means there must be a decimal place. But because it's dead on the 20, it's going to be 20.0 milliliters. Again, 1 decimal place. Let's go to the next one. Again, it goes up by 1s when you count it. We're going to read right where it's at. In this case, it's at 25.0 because it's dead on milliliters. Let's go to the next one. How much does each one go up by? Well, we got 20, 21, 22, 23, 24, 30. Well, that doesn't make sense to go from 24 to 30. So let's recount. Let's go up by 2s. So 20, 22, 24, 26, 28, 30. That makes sense. So we know this one goes up by 2s. So the answer is 22, 24. Well, it's in between 24 and 26. What's in between 24 and 26? 25. Notice how I didn't say 25.5. We don't know where 25.5 is. We just know in between here is 25. So if it goes up by 2's, you get no decimal places in the answer, and it's just 25 milliliters. That's how you read the graduated cylinders. Now the last thing you have is volume by water displacement. Water displacement is used to find the volume of irregularly or oddly shaped objects, meaning you can't use length times width times height. It might be a weird shape or something. When you're calculating this, the steps to do this would be, one, you need an initial amount of water in an empty graduated cylinder, so just water in there. That water is going to be your initial volume when you read it. That VI, that I stands for initial. Whoops, I misspelled initial there. Initial. And then you have down here, you add the object to the water. Well, when you add the object to the water is going to rise. When the water rises, that's going to be your final volume. And that's your VF, means final. Then to calculate the volume of the object or objects in the water, you have to subtract the initial from the final. That VO, that O, means the object. Let's look at an example. When you look right over here, we find there's nothing in this graduated cylinder. We find that each tick mark goes up by 1, so the initial volume, because there's nothing in there, just water, the initial volume is 4.0 milliliters. And again, we know it's milliliters because there's the unit. Then we add the objects, in this case, 2 red spheres. And the water goes up, and in this case it goes up to 6. So because everything goes up by 1, we get a volume of 6.0 milliliters. So then all you got to do is subtract. To find what the volume of the object, in this case the objects would be, is you take VF minus VI. VF is 6, VI is 4. So you take 6.0 minus 4.0, it gives you an answer of 2.0 milliliters. The mistakes that I see in all of this, 1 decimal place is all you can have. Reading this graduated cylinder off to the left here, you cannot write it as 4.00 milliliters. That is wrong. It can only be written with 1 decimal place. The same is going to be true back here. The answer comes out to be 60 cubic centimeters. 60.00 cubic centimeters would be wrong because we're adding decimal places that don't need to be there. Make sure you use this to copy everything into your notes. If you have any questions, please feel free to ask me. Thank you, everybody, and I hope you have a wonderful day.